Okay, welcome everyone. We have a big turnout today. Thank you so much for coming. It's really a great privilege for us to be hosting Mark. Mark is actually a lecturer at my alma mater, the University of Cape Town. It's really a big privilege for us to have him here today. He is a neuropsychologist and psychoanalyst, and he works at the Neuroscience Institute in Cape Town, which is, if you're looking for postdoc positions, maybe go to study South Africa. So Mark is going to tell us today about the brainstem basis of consciousness, which is a big part of his work, his life's work. If you have any questions, please don't hesitate to ask during the talk. He's quite happy with that.
No, after the talk.
You want after the talk?
Yeah.
Okay.
I'm very keen on questions, but after I finish. Unless something I'm saying is absolutely incomprehensible to you, I'll explain. But in terms of discussion, let's do that after.
Save it for the end. Okay, great. So save your questions to the end. We will also be getting to Lamb and Flag, and you're very welcome to join after for a few times. Please do come along. I'll let you get on with it.
Great, thank you very much. I'm delighted to be here. It's what I'm talking about is how we have overrated the role of the cortex in terms of our attempts to understand brain mechanisms of consciousness. So it's apt that I should come and deliver this message to the Cortex Club. So I'm very keen on us having a discussion at the end. So I'm going to try and just whiz through my talk, just giving you the headlines, so that we can have a good chat afterwards. That necessarily means, though, that I'm giving you headlines. I'm not going to be drilling down into any details. So the model that we've used for trying to understand the brain mechanisms of consciousness has been visual consciousness and therefore cortical vision. This is since roughly the 1990s. Cortical vision has been our model example of what we mean by consciousness. And Francis Crick's strategy was, if we can understand the if we can identify the neural correlate of visual consciousness, then we will be able to generalize from there to the rest of consciousness. That was the sort of strategy that we've all been following. It's not hard to understand why we focused on vision. And look at your conscious experience right now. I'm sure it's dominated by vision. A lot of cortex, as you can see in this map of the macaque cortex, a lot of our cortex is given over to vision. And as you can see from the famous information flow diagram to the right of it, we know quite a lot about cortical visual processing. So it's a good place to start. Had I more time at this point, I would go into the story about Mary, the visual neuroscientist. This is the famous knowledge argument and I'll just give it to you in a very brief and simplified version because of time. And it is simplified. This is not the original version of Frank Jackson. Imagine a visual neuroscientist who knows everything there is to know about the mechanisms, the functional, physiological, anatomical mechanisms of visual processing. But imagine that this person, Mary, that she's blind. So even though she knows everything there is to know about the functional mechanisms, the physiology, the physics, whatnot, of vision, she's never experienced vision. And then one day, thank God, the gift of sight is bestowed on Mary, and the point comes here. At that moment, she will learn something utterly new about vision. That everything she knew about the functional mechanisms of vision prior to that did not prepare her for what it is like to see. And in fact, it didn't even contain within it this mechanistic knowledge that she had any prediction, any expectation, any reason why there should be something it's like to see. So the alarming conclusion that flows from this argument is that the actual experience of vision, the actual qualia of redness and blueness and whatnot, exists somehow outside of our ordinary mechanistic account of everything. So consciousness somehow is in some spooky place outside of normal science. That leads to this famous question. This is the hard problem of consciousness, as formulated by David Chalmers. Why is the performance of these functions, visual functions being the model example, why is the performance of these functions accompanied by experience? Why doesn't all this information processing go on in the dark, free of any inner field? And Chalmers, of course, wasn't the first person to ask this question. He built upon a long tradition, and I want to mention one of them, which is Tom Nagel. A good 20 years before Chalmers, he asked this question: why and how is there something it's like to be an organism, something it's like for the organism? So hold this philosophical question in mind in relation to that argument in relation to Mary. How come a knowledge of the functional mechanisms is possible without there being any reason why there has to be something it's like, some experience that goes with this information process? And why can't these mechanisms just run like any other mechanism? Why does it have to feel like something, and what is the feeling for? What does it do? That's the hard problem. And now, as I forewarned you, I'm going to address this problem by saying that I think we're looking in the wrong place. I think that cortical visual mechanisms of consciousness is not a good starting point. It's not a good model example. Had we rather looked to brainstem mechanisms of consciousness, this problem would never have taken the form that it has. And my whole talk is going to justify my saying that. So I hope it's clear what I'm saying, because this is what I'm going to try and justify. We shouldn't look to the cortex. We shouldn't look to visual perception. This is not a good place to look in order to understand the mechanistic basis of consciousness. We should rather be looking to the brainstem. I'll say again, it's not surprising that we started with vision. It's not surprising that we started with any perceptual modality. It's not surprising that we started with the cortex. There's all sorts of reasons why we started there, not least of them being that our consciousness, and again, I said to you, look at what you're experiencing now, and I emphasize vision, but look at everything that you're experiencing now. It is made up of the qualia of the different special senses. You're seeing things qualitatively, you're hearing things, you feel things somatosensorily in your body, and if you're unfortunate enough at the moment, you might smell something, and if you really want to, you could taste something, but that's it. These are the raw ingredients of consciousness. Consciousness is made up of these properties, and they are the properties of perception of the special senses, and we know that they are all projected, the special senses are projected onto particular zones of cortex, and if you lesion those zones of cortex, you lose those qualities. And if you stimulate those zones of cortex, you generate those qualities. And so, clearly this is the place to look. I say again, I don't think it's surprising that we started there, but it turns out to have been unfortunate for reasons that I've explained. So I'm now going to start telling you why it's a problem, okay? Why it's a problem that we started with the cortex and with perception and visual perception in particular. Here is the title of a famous review paper, also published in the 1990s by John Kielstrom, the title of which says it all. Perception without awareness of what is perceived, learning without awareness of what is learned. Let's focus on perception, since I'm saying this is not a good starting point. My first argument is, but you can perceive unconsciously. Why do you look to a function that is not intrinsically conscious? And then you would say, well, the cortical part is conscious. And the point is, that's not true. That cortical perceptual processing is not intrinsically conscious at all. There's all sorts of examples for that, and they're summarized in this article by Kielstrom. But I'll just give you, I'll sort of zoom in to one particular study to illustrate the point that I'm wanting to make. In this study, research participants looked in a tachistoscope, which is an apparatus which enables you to flash visual information extremely briefly in milliseconds, so briefly that you don't see anything at all consciously. But you're able to demonstrate subsequently by dint of the behavior of the participant that they have been influenced by what they've seen. So clearly, unconsciously, they've seen something. So in this particular experiment, two faces are shown to the research participants in the tachistoscope. Subliminally, very briefly, unconsciously, they're shown two faces. Face A has written under it the word rapist, and face B has written under it the word philanthropist. After this unconscious presentation of these stimuli to the research participants, they are then supraliminally shown those two photographs and asked, in a forced choice paradigm, they have to choose which of these two people do you prefer. And with an enormous degree of significance, they choose face B. And the question is why? They've never seen, as far as they're aware, they've never seen these people before, but we know why. It's because of how they're labeled, how they were labeled unconsciously. What that experiment, and it's just one amongst thousands, what that experiment demonstrates is that it's possible to see unconsciously, to recognize faces unconsciously, and remember this is a cortical function, and more importantly, to read with comprehension unconsciously. This is a uniquely human cortical function. So you can see unconsciously in a way that is clearly cortical, even at the highest level of reading with comprehension. So the highest specifically human cortical visual functions do not require consciousness to operate. So it's not entirely surprising that somebody like Mary can know everything about how vision operates without knowing anything about why it feels like something. It's because it does not have to feel like something. You can do this visual cortical thing without consciousness. So why did we start there? I start now to question it. Perhaps this is not such a great place to look, looking at a function that does not have to be conscious, that is not intrinsically conscious. So I've said, I thought we should rather be looking at the brainstem. And why do I say that? Well, there's one very obvious reason why, and that is as long ago as 1949, Magoon and Maruzzi discovered that there is a part of the upper brainstem which came to be known as the reticular activating system, which, if it's lesioned, the lights go out. They studied cats, but we now know this is true of any creature that has a reticular activating system. You lesion that part of the brainstem and consciousness is obliterated. The obvious point that I need to make is that this is not perceptual. This part of the brain is not receiving information from the outside world. This is an endogenous activation from the innermost core of the brainstem. So consciousness does not seem, in fact, despite our intuitive experience, it doesn't, in fact, flow in with perception. In fact, it's something that's generated from the deep core of the brainstem. It's endogenously generated. And then it activates cortex and renders cortical information processing, which I say again is intrinsically unconscious. It's rendered conscious by modulation, activation, arousal from the reticular activating system. Magoon and Maruzzi showed that if you sever the ascending axons from the reticular activating system, that modulate cortical information processing. If you snip those pathways, then the cortex is rendered unconscious. So that seems pretty conclusive evidence that this is where consciousness is generated in the brainstem, and that it is not, in fact, a perceptual function, it's not a cortical function. So why, well, let me first show you this. This is a more recent, we can now identify what Fisher et al. Call a coma-specific region. The tiniest lesion in the human brain that reliably produces coma is a 2 cubic millimeter area in the parabrachial complex. So this tiny little part of the, I mean, imagine, this is the most concentrated consciousness-producing tissue that there is. Tiny, tiny lesion, the size of a match head in the upper brainstem, in the parabrachial complex, can entirely obliterate consciousness. That's not to say that that's the only lesion site. I mean, more or less any lesion in the reticular activating system sufficiently large is going to obliterate consciousness. This is the smallest lesion that is associated with coma. So I was saying, given all of this, why don't we look there? Why has this not become, since 1949, the place that we look to in order to understand the brain mechanisms of consciousness? And I'll tell you why. It's because of the way in which Magoon and Maruzzi interpreted their findings. And their interpretation is the one that has been handed down to successive generations of neuroscientists ever since. This is what I learned, and I'm sure it's what all of you learned, and I hope that you will be willing to listen to my arguments as to why what I'm about to summarize for you that you've learned and you probably believe. I hope that you'll be open to being dissuaded of this view. The view was that there are two aspects to consciousness. That there's a level, which is a purely quantitative dimension, what we measure on the Glasgow Coma Scale, for example, level of wakefulness, a quantitative scale, and then there is the contents of consciousness, the qualities, the actual stuff of phenomenal experience. And those two aspects were assigned from Magoon and Muruzzi onwards to the reticular activating system and the cortex respectively. So the reticular activating system is responsible for this quantitative level dimension of consciousness, but the actual qualitative phenomenal stuff of experience, the contents of consciousness, are cortical. And the argument is basically this. The analogy that they used, and which is frequently used, and I think it's a very good one for illustrating this way of thinking, is that the brainstem, and in particular the part of the brainstem I'm talking about, is a power source for consciousness. So the cortex is something like a television set, and the reticular activating system is something like an electrical power source at the wall. You've got to plug the television set in and switch on, the power source. Otherwise, it can't do its televisual thing. But that doesn't mean that really television comes from the power source in the wall. That's just a prerequisite. It's a necessary first step. You've got to boot up the television set, then it does its televisual thing. And all the stuff that we really mean by television, the contents, the qualities, the programming, all of that is clearly performed by the television set. So on that analogy, the actual stuff of consciousness, its contents, its programming, its qualities, is cortical, and it has to be plugged in at the reticular activating system. For that reason, the reticular activating system is not particularly interesting. It's just a necessary prerequisite. But the real stuff, the real mechanisms are cortical. So now I'm going to set out a case as to why I think that is not true. Why, in other words, I think that it's wrong to suggest that what the reticular activating system is supplying is a mere power source, that there's no quality, no content to what the reticular activating system is doing as far as consciousness is concerned. I'm going to give you a number of different types of evidence that I believe strongly suggest that what the reticular activating system is providing does have quality and does have a content of its own. So I'm going to give you some exhibits, and each one of these exhibits is just that. It's an instance. I'm not going to be reviewing, plowing through tons and tons of literature. Just take it that these are representative examples of different types of evidence that we have. I'll start with what is probably the most dramatic, and that is this. These are kids with a condition called hydranencephaly. That is to say they're born without cortex, that they're born with cerebrospinal fluid in place of where the cortex should be. That's a very good test of the theory that I've just expounded. If on the Magoon-Muruzzi view, if the cortex is responsible for the actual qualitative contents, the actual phenomenal stuff of consciousness, these kids should not have any. Since they have only an intact brainstem when it comes to, here's what I want to, this is an amazing thing, by the way. I never knew that you could do a pointer like this. So there you see, there's an intact brainstem. On the Magoon and Muruzzi view, the standard view, the view that I was saying I hope to be able to open the possibility that you'll start to question this view. On that view, these kids should only have the power supply. They should only have this quantitative level of consciousness, but it should have no content, and it should have no quality. It should have no phenomenal field. There should not be anything that it is like to be such a child. It's a great test of the theory. I'm going to show you that there's evidence to show that that's wrong. Now, what is it? So these kids would have a level of consciousness without any content. I mean, sort of hard to imagine. What is that? What is a level of consciousness that has no qualities, that has no content, that has no actual consciousness? And I think the best clinical equivalent of that is the so-called vegetative state, non-responsive wakefulness. So these patients have a sleep-wake cycle. So in other words, there is a sort of a rhythm where their brain is booted up and then booted down and then booted up, but they do not respond to the environment. There's no actual content to what they're doing. It's just a sort of an autonomic sleep-waking cycle. So that's what you would expect if that theory is correct, but that's not what you find. Here is the child whose scan you've just seen, and it's this one. She's 3 years old, and there you can see she's awake. You can see she's conscious in the sense of a level of consciousness. But most importantly, you see what happens when her baby brother is placed on her lap. She responds. Remember the definition of the vegetative state? Non-responsive wakefulness. Here is a responsive child. And what is more, the response has quality. It is, she's happy. She likes it. This little baby brother has been placed on her lap, and it generates a feeling with a particular quality. It is an affective response. I said earlier, that your consciousness is made up of these 5 sensory modalities, but of course there is this additional one, feelings, affects. They don't flow in from the outside. They are your subjective contribution to what's flowing in from outside. So this patient has consciousness. That consciousness is not perceptual, and I'll come back to that in a minute. That consciousness is affective, and that means it has quality, and that means it has content. She's by no means a rare example, this kid. Here's another such child. Tell me that this patient, that there's nobody home. Okay, there she is responding emotionally, and these kids respond emotionally not only with happiness, they respond emotionally in an appropriate way depending on how you stimulate them. So you place the little baby brother on her lap, and she's happy. Try taking that baby brother away from her, and you have her going, arching her back and protesting. She feels pain. You can startle her by clapping your hands, etc. There are a wide range of basic emotional states displayed by these kids. I said I'll come back to the fact that it's not perceptual consciousness. And here's the slide by which I'm going to do that. Many people think, but how can the child respond to the baby brother being placed on the lap if she's not able to have perceptual experience? And that is because she is perceiving somatosensory information, visual information, auditory information, and so on, is being processed by her brain, but not by her cortex, because she doesn't have cortex. It's being processed subcortically. It's being processed in the example I'm giving on the screen at the moment, and this is the example of vision, just because it's easiest to illustrate. Here is her eye, and of course, the optic nerve goes to the lateral geniculate, and from there to the occipital cortex, where you have conscious vision, but the same nerve also projects to the superior colliculi, where you have unconscious vision. And this is not unique to vision. The same applies to somatic sensation and hearing and so on. So this child does actually register the presence of her brother on her lap. That perceptual information is registered unconsciously, and then she has a conscious emotional response to it. And if that sounds weird, just think back to what I said about the tachistoscopic experiment. These are people who have seen this face unconsciously, and they have an emotional response to it. They just don't know where the emotional response. So they feel something, they don't know where that comes from. We know where it comes from, just as we do here. We know the superior colliculi are processing this information unconsciously. So in these kids, they are receiving information about the outside world, but not cortically, so it's not conscious information about the outside world, but they are awake, and they respond to that information with a particular quality and content called emotion or affect. So that's my first exhibit. It is hydranencephaly. You can do the same much more precisely with decorticate other mammals. You see exactly the same thing. Remove cortex from a newborn rodent or a newborn cat. They respond like these kids do emotionally. They are not by any means in a coma, and they are not by any means vegetative. When I present this data to colleagues who have less open minds than I hope you have, they say, well, how do you know these kids are conscious? These are just behavioral responses. They could just be reflexes. They could just be instinctual stereotypes. And I have to say to you, first of all, remember these are colleagues who've never interacted with these children. I mean, it's really very hard to believe that these kids are not conscious, any more than it's hard to believe that your bounding Labrador isn't conscious, you know, or your pre-verbal infant isn't conscious. You don't need to report conscious states verbally to be able to see the evidence that here you have behavioral evidence of a feeling sentient being. But, you know, they're right. It's possible. I mean, even though these are they're not purely reflexive, they are, you know, individualized responses by these kids. It's possible. It's possible that they're not conscious, that it just looks as if they're conscious. So how do we get around this methodologically? Well, we have to try some other way of testing the hypothesis that the upper brainstem generates affects and you can report those affects. So in other words, you need to use a method where the cortex is intact and you stimulate these brainstem structures. The prediction there, the falsifiable prediction there would be if you stimulate these structures, you should be able to generate intense affective states. Now, you can't just go around sticking electrodes into people's brainstems to see what happens, but there are clinical situations in which we do that. And here again, I'm going to give you just one example. This is by no means a unique example. It's a case of a patient, I think she's 65 years old. She has Parkinson's disease, and a electrode was placed into her brain, aiming for the subthalamic nucleus, which is what one aims for in the treatment of Parkinson's disease. But this went a little deeper, and it went into the substantia nigra. Substantia nigra, of course, is part of the reticular activating system. So let's see what happens when you stimulate the substantia nigra in the way that happened in this case. Remember, she's 65 years old, has Parkinson's disease. What I haven't added is she has no psychiatric history. This patient's never had a psychiatric diagnosis in her life, and in particular, she's never suffered from clinical depression. What happened when within 5 seconds of switching on the electrode is that the patient started to cry, and she verbally communicated feelings of sadness, guilt, uselessness, and hopelessness. She said, "I no longer wish to live, to see anything, hear anything, feel anything." When asked why she was crying and if she was in pain, she said, "No, I'm fed up with life. I've had enough. I don't want to live anymore. I'm disgusted with life. Everything's useless, always feeling worthless." When asked why she was sad, she replied, "I'm crying over myself, of course. I'm hopeless. Why am I bothering you?" This is depression. In fact, suicidal depression, brought on within 5 seconds of switching on the electrode. And when switching it off, 90 seconds later, this intense affective response disappeared. This patient very kindly allowed the surgeon to switch it on again. And in fact, in a fashion where she wasn't sure whether he was stimulating in the substantia nigra or in the subthalamic nucleus. Whenever he stimulated in subthalamic nucleus, there was no affective response. When he stimulated in substantia nigra, the depression came back. Remember, I'm giving you one example. This is by no means a unique example. Stimulate in the brainstem in humans and animals, you get intense affective responses. You get way more intense affective responses than anywhere else in the brain. And this applies not only to the reticular activating system, but also to the periaqueductal brain. You get the most intense and the widest range of affective responses from stimulation of the upper brainstem in the periaqueductal gray or the reticular activating system. So remember, I'm saying the brainstem, these structures that switch on the lights, I'm saying that the lights that they switch on have a quality and a content. And again, we see it is affective. It's intensely affective. It's not just the power supply. This is quality. This is phenomenal. This is contentful. This is a feeling state. And again, remember, that's just one example. And the reason why I'm showing you this example is because here's somebody who can report. So we're testing using a different method, testing the predictions that flow from the hypothesis that the feelings are actually generated by and in the upper brainstem. So here's my third exhibit. Another method that we can use is we can image the brain using functional neuroimaging. We can image the brain when people are in intense affective states, and we can predict if the affects are being generated in these subcortical structures, that's where the activation will be seen on imaging. And that's exactly what you see. Here again, just one paradigmatic example. This is Damasio's PET imaging study of 4 intense affective states. And what you see in each of those examples, sadness, anger, happiness, and fear, is that the epicenter of the activation is subcortical, and in particular in the brainstem. So this is a third method showing that the affects are actually generated there. I should have said, by the way, when I spoke about brain stimulation, that you can generate affects by stimulating the cortical surface, but they are faint copies. They are like memories of affects. Memories of episodes when affects were really nothing like the raw feeling that is generated with the brainstem stimulation. One last exhibit, that is what happens when you modulate the neuromodulators, when you regulate them up and down, the ones that are sourced in the reticular activating system. If this was just a power supply, then what you should be doing is raising and lowering the level of consciousness in a way that an anesthetist might aim to do. But it's not anesthetists who tinker with these neuromodulators that are sourced in the reticular activating nuclei. It's psychiatrists who do so. So there are some outstanding examples. Serotonin, increased serotonin is supposed to improve your mood. It's an antidepressant. Noradrenaline is associated with anxiety. It's targeted in many anti-anxiety medications. Dopamine is targeted in antipsychotic medications. So as I say, if all that these structures were doing was regulating up and down the level of consciousness, then it might be something that anesthetists tinker with, but it's not. It's what psychiatrists tinker with. It's because what these systems do is generate affect. They generate this content, this quality of consciousness. So what I'm saying is that the upper brainstem, which is intrinsically consciousness generating, that's what these structures are there for, unlike the cortex, which, as I showed you, again with reference only to very small examples, cortex can do all of its information processing, its perceptual information processing at the highest possible levels. It can do it without consciousness. It's not intrinsically conscious. This part of the brain, its whole function is to generate consciousness, and it's not just a prerequisite for consciousness, it actually has quality. And that quality is affect, and I'm saying that is it seems that the fundamental form of consciousness is affective. Because if this is the prerequisite for all the other forms of consciousness, if this is what boots up the cortex and renders unconscious cortical information processing conscious, then this thing that renders it conscious is feeling. So there's a kind of feeling your way into your cognitive and perceptual processes. I must whiz through on, I must hurry. Sigmund Freud, the discoverer of the unconscious, the person who more than anybody else argued that mental processes do not have to be conscious. They're still mental processes. With reference to perception and cognition, Freud argued this. But even him, who has the greatest reason to want to argue that mental processes go on unconsciously, even him, he says, it's surely of the essence of an emotion that we should be aware of it, that it should become known to consciousness. Thus, the possibility of attribute of unconsciousness would be completely excluded as far as emotions, feelings, and affects are concerned. And I've emphasized the word feelings because different people mean different things by emotion and affect, but surely we all mean the same thing by feeling. It's a feeling, you feel it. It's an absolute oxymoron to speak of an unconscious feeling. If you don't feel it, it's not a feeling. So let's focus on that. I'm saying that this upper brain stems, the periaqueductal gray and the reticular activating system, these structures generate a raw, basic, fundamental form of consciousness, and it's called feeling, raw feeling. That's what we're talking about. And this, I'm saying, is the basic fundamental form of consciousness. And had we focused on that in the first place, the whole problem would have looked very different. So here's a little summary I'm saying that cognition and perception, cortical functions, are mainly unconscious. Feeling is always conscious, it's intrinsically conscious, and it's not just, please note, a semantic point. It's not, I'm not just saying linguistically you can't say that you have a feeling that you don't feel. I'm saying the brain structures that generate feeling are the consciousness generating structures, and they are prerequisite for any other form of consciousness. So I'm not saying the cortex doesn't contribute to consciousness. I'm very grateful to have cortex. I don't want to forfeit it. I'm very grateful to have all the types of consciousness that my cortex supplies, but all of that is derivative, all of that is secondary, all of that is only made possible by the fundamental form generated in the upper brainstem. So let's return to David Chalmers, and I'm not going to read this whole thing. Just look at the bold part. This is the essence of Chalmers's argument. His argument, the one that I started with at the beginning, why doesn't all this information processing go on in the dark? He says there is no cognitive function such that we can say in advance that explanation of that function will automatically explain experience. So you see, think about the Mary story. Mary can explain the function of vision, but it doesn't automatically explain why you experience it. That was where we started. I think the problem here is with this word. There is no cognitive function. That's what Chalmers is talking about. If we replace that word with affective, if we were to say there's no affective function, such that we can say in advance that explanation of that function will automatically explain experience, I'd say that's not true. And I've just told you why. The function of feeling. You cannot explain the function of feeling without explaining why it feels like something. So I'd say you can say in advance that explanation of the function of feeling will automatically explain experience. And this is why I'm saying we should have started there. Had we started there, we would be looking at the right model example of consciousness, the fundamental form, the elemental form, the basic form, and we should extrapolate from there. So in the few minutes left, let me dive into this question of what is the function of feeling? It seems to be an extended form of homeostasis. It's no accident that those brainstem structures, the parabrachial complex and the periaqueductal gray, have everything to do with homeostatic functions. So let me remind you how homeostasis works. There's a settling point, it's where we need to be. And the deviation from that settling point is a demand for work. Something has to be done. Something has to be done to return you to your viable bounds, to your core body temperature or hydration level or salt level or sugar level or blood pressure or whatever. That's where you need to be. Deviations from it that go too far are incompatible with life. So you have to do something that responds to that demand and brings you back into your viable range. And that work that is demanded by the deviation, what kind of work is effective, there has to be some sort of prediction, some sort of built-in mechanism that when, for example, one gets too hot, what one does is pant and sweat, and then you cool down. Or when one's blood pressure goes too high, what one does is one reduces the heart rate and dilates the vessels, then blood pressure will go down. I call these predictions. Of course, that sounds a little bit odd because it's not conscious cognitive predicting. These are predictions that are given by natural selection. What works, what has worked over eons of time, gets built into our brains as the prediction as to how one should respond to a homeostatic deviation of this, that, or the other kind. Now, that's all well and good, as long as you are in the expected situation that prediction is predicated on. But there are many situations in life which are not predicted by natural selection. There are many novel problems. So let me now illustrate very briefly why this homeostatic mechanism extends onto feeling. I'll use the example of breathing. Breathing is an autonomic reflex. Breathe in, breathe out, it all happens automatically. My oxygen level's too low, breathe in. My carbon dioxide level's too high, breathe out. And that blood gas balance is maintained just like that. But it assumes that there's a certain amount of oxygen in the ambient environment. If there isn't, then that prediction no longer works. All I need to do is expand my intercostal muscles and then I'll be fine. That doesn't work anymore. If you're in a carbon dioxide filled room, if you're in a burning building, you don't know what to do. You've never been in a burning building before. Breathing doesn't work. So feeling kicks in. Feeling tells you this is bad. What does that help? Why does it help to feel? It's because you're now going to behave randomly. You don't have an inbuilt prediction as to what to do. So you need to know whether what you're doing is working or not. So I go upstairs. If I do that, I find the feeling of air hunger, the suffocation distress gets worse. So I change my mind and I go downstairs instead, and then it feels better. So the feeling tells me you're going in the wrong direction or you're going in the right direction before it's too late. It's an enormous adaptive advantage. So it's exactly the same sort of thing as this, except now the demand for work, the deviation, the going in the wrong direction is felt, and the successful work, the going in the right direction is felt, so that you can base your choices, and I emphasize the word choice because now we're talking about voluntary behavior, you can base your choices in a value system. The value system is the basic value system of all living things, namely it's good to survive and bad to die, except now you feel it. That's what pleasurable and unpleasurable feelings are for. So what we're talking about here is a mechanism, a function. It's a mechanism, however, that necessarily must be felt. That's what the whole thing is for. Please note, it's a subjective, you are monitoring your own state. It's intrinsically subjective. This is good or bad. It is intrinsically balanced. It's intrinsically good or bad, but only for the organism that is actually registering its own state. It's good or bad for me, not for the universe. There you have something that's intrinsically balanced. In fact, here the value is existential. And then what is more, because we have multiple homeostatic needs, it is also necessarily qualitative. So it's necessarily subjective, it's necessarily balanced, and it's necessarily qualitative. And let me explain what I mean by that. I mean, 8 out of 10 of thirst is not the same as 8 out of 10 of sleepiness. These are different needs. You can't add them up and say 8 out of 10 of thirst plus 8 out of 10 of sleepiness makes 16 out of 20 of total need. Okay, I'll just sleep. You'll reduce the continuous variable of need, but you'll die. That's because each one of these organismic needs has to be met in their own right, which means formally they have to be treated as categorical variables. And categorical variables are qualitatively distinct. That's why 8 out of 10 of sleepiness is not the same as 8 out of 10 of thirst. There you have the ground zero necessity for quality, for qualia. So I'm saying that this mechanism, the mechanism of affect, unlike the mechanism of visual perception, necessarily has to be felt. Its fundamental mechanistic properties are subjective, valuative, and qualitative. So if Mary, the blind visual neuroscientist, were in fact an affective neuroscientist, she knows everything about this mechanism, but she's never had a feeling. In fact, if she knew all about this mechanism and never had a feeling, she'd be in the coma, she'd be dead. So it's not possible. But I mean, just imagine, this is what philosophers allow themselves to do. Imagine that Mary is an affective neuroscientist. She knows this mechanism that I've just explained to you. It will not come as a surprise to her when she's now gifted with consciousness to experience it as, oh, I see, it's got a goodness and a badness, and it's for me, and it has different qualities. All of that is predicted by the mechanism. So I'm saying, had we started there, had we used affect, had we used the brainstem form of consciousness as our model example, then this question would not be puzzling at all. Why and how is there something it's like to be an organism, something it's like for the organism? Well, duh. And this question, why is the performance of these functions accompanied by experience? Why doesn't all this information processing go on in the dark, free of any inner field? Well, it couldn't. It is possible that the information processing entailed in the function I've just described to you could go on without inner field. That's its whole purpose. That's its whole function. So I'll stop there. There's one further slide which I won't bore you with, which is just to say that it seems we can reduce consciousness, at least its elemental form, to a mechanistic causal explanation, just like anything else in the universe. But I won't go further on that score now, because I promised to stop in time for some discussion, and that's always the most interesting part. Thanks very much.
you're claiming at the end that looking at consciousness as this affective state will solve the heart problem, less of the heart problem. But what do you say? Is there no heart problem with a person with a lesion in the amygdala can talk about emotion without feeling the emotional state? I'm not sure I'm convinced that, or if you explain emotion in dry fashion, it will it will predict the emotional state.
Yes, so I must just repeat the question because I presume that it's not that the online audience can't hear it. So the question, to the extent that I'm understanding it, and therefore you also have an opportunity to correct my understanding of your question. The question is, well, there are examples, for example, Urbach-Witte patients who have no amygdala, that they can still describe verbally and cognitively, intellectually, they can describe what fear is, even if they don't actually have the raw feeling of it. And so she's not, the audience member is not convinced that emotion necessarily involves an actual feeling state. So look, this is partly why I said emotion means different things to different people and affect means different things to different people. So let me talk about feeling. What I'm saying is that what you've just said does not apply to feeling. You're saying it's possible to talk about emotion and to talk about affect without actually having the raw feeling. And I'm saying, fine, I'll grant you that. That's not what I'm talking about. I'm talking about the part of the brain that generates the raw feeling turns out to be the part of the brain that generates, that is necessary for any form of consciousness. And that form of consciousness does just have that property, raw feeling. So I'm saying that that is the fundamental form of consciousness. My argument doesn't rest on it is necessary to experience every type of thing that we call an emotion. My argument rests on the fact that this raw feeling, affect, is the fundamental form of consciousness, and its mechanism necessarily implies that you have to feel it. That thing that part of the brain generates must be felt. That's what its whole function is. That's what it's for. Thanks.
So regarding the homeostatic explanation, there are reinforcement learning models and virtual agents that can help them balance different types of needs. And so is having the affective state necessary, therefore, for functioning in the world? Or why would consciousness emerge?
Yeah. So the question that I'm asked now, and again I'm repeating it for the online audience, is it not manifestly true that there are forms of learning that occur that do not require consciousness? Reinforcement learning in artificial agents clearly can't depend on consciousness, and so that's the question. And I will extend it and say, and there are many living organisms, because they're living, they're necessarily homeostatically regulated, and they clearly learn. So, it seems as if learning is not contingent, learning from experience is not contingent upon feeling. Is that what you're saying? So I would say learning from experience adds something that is beyond just mere learning. I absolutely grant you that learning is not predicated upon. There are indeed examples of learning biological and non-biological agents where there's very little reason to believe that we're dealing with learning from experience. In other words, learning from feeling your way through the problem. So the sort of functional criterion then becomes an organism that has this function that I'm talking about. It should be able to solve a novel problem. It should be able to feel its way through a problem, come up with a solution for which there is no pre-programmed mechanism. That would show that what it's using, the choices that it's making in the solving of this problem would be rooted in feeling. I agree, I absolutely agree, it's not the only way in which learning can arise, but I think learning of this kind, learning to solve a novel problem, how to survive in a situation for which there's no evolutionary preparedness, would be a good litmus test of whether this functionality is there or not.
Should make understand what kind of consciousness you are talking about.
Yes.
That consciousness, by your definition, let's say, characterized only human for animals as well. Capitalism, in your description, I believe it is same consciousness being as human. Is that correct?
So if I'm understanding this question, and again, I'm repeating it partly for the online audience and partly for you to tell me if I've got it right or wrong. Consciousness, as I'm using the term, is it a uniquely human property or does it apply to other animals too?
Yes, for me, what you described, it's not unique for humans.
Yes.
It's same as any animal we choose.
Okay.
So self-awareness, please try to explain now how you expect self-awareness in your model of consciousness.
Yes.
Because self-awareness is crucial to try to understand what consciousness is.
Okay. So I had understood his question correctly, and he's elaborated it further, but I'll stick with how I've summarized it so far. Absolutely, the way I'm using the word consciousness is referring to something very basic, and it's something that is by no means uniquely human. In fact, I think that if we can tie this thing that I'm calling consciousness, the most basic form of it, to the functionality of the upper brainstem, the PAG and the reticular activating system, then I would say that any creature that has that anatomical architecture is capable of consciousness. And in fact, all the evidence supports that. So all vertebrates, I would think we have an empirical criterion beyond the functional one, and I'll come back to the functional one in a moment. We have an anatomical criterion for determining whether or not a creature is conscious. If it has this anatomy, then I would say there's every reason to believe that it's conscious. And in fact, if you then test predictions arising from that hypothesis, they always confirm. Like, for example, stimulate this structure, it will be aversive. Stimulate this structure, it will be rewarding. And they're very interesting experiments, like, for example, with zebrafish. Put them in a tank where food is delivered on this side of the tank, and they obviously congregate there. That's conditioned place preference behavior. Then you put something on the other side of the tank. The only thing that it has going for it is it's pleasurable, like cocaine or morphine or amphetamine or even nicotine. And you find the zebrafish now hang out there. So that's hedonic place preference behavior. It shows that there's strong evidence to suggest that they're feeling something. That's the feeling is what's motivating them to go to that side of the tank. So this is the sort of evidence I'm saying supports the idea. Your problem, your grievance or your complaint to me is, well, that's not what we mean by consciousness. And I'm saying, well, on Nagel's definition, there's something that is like to be the organism, something that's like for the organism. That is, I think, an absolutely basic definition of consciousness. I think that obviously that doesn't define or describe everything that we mean by the word consciousness. But my point is twofold. The first is that, as with anything else in science, let's start with the elementary form. That's, if you're wanting to understand consciousness, don't start with self-reflective access consciousness a la Med Block and so on. Let's start with the most basic form. Then we extrapolate from there. Remember, Crick's argument was, let's start with vision. Once we've cracked that, we can extrapolate from there. And I've told you why I think that was a bad place to start. But the same strategy applies. Start with the most basic form. And this is, I think, the most basic form. Then you generalize from there. But remember, the second thing that when I said there's two reasons for this, I'm saying one is that's the most basic form. That's a good place to start. But also it's demonstrably the case that all the other forms cannot exist without this form. So as much as I take it and grant you that reflexive, self-aware consciousness of the kind that we humans take for granted, that this is something way beyond just raw feeling, I'm saying it is absolutely contingent upon raw feeling. It is some extrapolated, extended version of raw feeling. I believe that we start with, consciousness starts with, I feel like this, not in words, just I feel like this. And then secondly, it's a matter of, I feel like this about that. And it's an extending of the feeling onto the environment that is generating that feeling and the environment in which you're acting, trying to resolve that feeling. But I think that it's a big problem in consciousness studies that we all mean very different things by that word. So I'm saying two things. That's what I mean by the word, and I think that's the right place to start. Thank you.
I love the illustrative mini-binary exhibits where the construction of the parabrachial region showing sort of the colon, and then lighting up at least part of the brainstem to show affect. And I'm aware that with ME chronic syndrome, where there's sort of,
sorry, with which syndrome?
ME chronic.
Oh, ME, yeah.
With the brainstem compression or malfunction, some that symptoms can be better or worse, and there's on comparisons with hibernation modes. And I wonder if there's any other non-binary kind of pathology that illustrate a curve rather than just sort of on or off. You know.
So the question is, the questioner said he likes the binary examples I gave of, like, you know, a parabrachial nucleus lesion coma, intact parabrachial complex no coma. So these kinds of binary examples, stark illustrative examples of what I'm talking about. But what about more nuanced sort of versions? And he refers to, for example, myalgic encephalomyelitis. Are there non-binary examples? Are there other examples that we could use just to sort of fill in the gap between the extremes? And I think I did give one. I think that there are many such examples, but I think that I did give one in my talk just to illustrate the sort of thing that I'm talking about. That is modulating these neurotransmitters, serotonin, noradrenaline, dopamine. For my sins, I think that every psychiatrist should do this. I've taken all these drugs to see what happens. What does it feel like? You know, I can tell you from my own personal experience, as you take more and more dopamine, so you are changed in a very interesting way. You know, and as you block dopamine, so you are changed in another interesting way. And that's very different from, say, for example, taking a little bit of morphine. So the qualities, they're very different qualities, and the degrees by which you can modulate them fill that gap that you're saying between consciousness on and consciousness off. So I think, you know, that's one example, but I think that there must be many others. Thank you very much.
I totally buy the argument that affect helps us navigate, like it acts as a kind of internal signal. But I'm not sure I follow why that's necessary. Like if you were building a system from scratch, it comes back to our own argument. You can build systems which can deal with uncertainty, can do Thompson sampling, or, you know, you can seek novelty. But you seem to be saying it's necessary. So why is affect necessarily different from other forms of information?
Okay, so I'm going to summarize this question in a very truncated form. He's saying, are there not other ways of navigating uncertainty? Are there not other ways of other decision-making processes which don't necessarily involve affect? So let me preface my answer to that by saying, first of all, in fact, one of the earlier questions, I don't know which one of them it was, but I intended to say this. So I now regret that I didn't say it, so let me say it. I don't think that the hard problem of consciousness would ever have arisen had we not started with the model example that we did. I think that it's so like kind of obvious, you know, that when I say, I had this slide of Nagel's, you know, I said, well, you know, why does this puzzle anybody? You know, I mean, what is Nagel puzzled about? Because he's talking about perceptual processes. He's not talking about these affective processes which arise from the organismic needs of living creatures. Had we started there, you know, we would. So, you know, this is clearly how consciousness arose, is what I'm saying. I think it's like really strongly, intuitively, and empirically, you know, a good line of argument. Does that mean that it's the only way that we could have solved this biological problem? Is it not possible that the problem of how do you deal with unpredicted environments Well, you know, the same applies to, for example, ambulation. There are many different ways we could ambulate. It just so happens legs work really well. So, you know, legs evolved, they work really well, and so we kept them. We don't have wheels. We could have had wheels, but we don't. So I'm not saying that it's inconceivable that the same functionality could be achieved in other ways. I'm just saying this is the way in which it was achieved. And so we've thereby explained how consciousness arose. But I would like to go a little bit further than that. I think that when you describe the mechanism that I've described, when you say what you're dealing with here, and I'm going to elaborate it a little bit more than I did in my talk. You're talking about a self-organizing system, which is what all living things are. They're self-organizing systems. Self-organizing systems, the basic design feature of them is that what they do is to continue existing. So their most basic functional property is they must act so as to continue to exist as a system. They don't dissipate, they don't just, and that's, by the way, where homeostasis comes in. Homeostasis is precisely a mechanism that disallows exploring all possible states. You have to stay within your viable states. This is essential to self-organizing systems. So we have a self-organizing system, and I'm deliberately using that word rather than biological system because of your question. You have a self-organizing system that necessarily has values. In other words, there are states that are good and bad for it. From the point of view of the system, these states are bad because they go against my continuing to exist as a system. These ones are good. Mechanistically, I'm speaking. And then, as I've said, there's an intrinsic value to those, and they're intrinsically subjective too. Okay. Then added to that is the point that I made toward the end of my talk. And if such a system has multiple needs, in other words, multiple homeostatic set points, then they must necessarily be treated as categorical variables. So such a system must register its states qualitatively. They will necessarily have value to the system, for the system, and they are subjective states of the system. I'm saying that mechanistic account is just a mechanistic account of what a feeling is. And I would say that any self-organizing system that has those properties, if we allow ourselves to not be prejudiced, and it goes back to your question about reinforcement learning. I mean, a reinforcement learning agent does not have those properties, but an active inference agent might have those properties. And this is why I ended with this slide, but didn't go into it. I think that if we're claiming that this is the mechanism whereby feeling arises, and I've just told you why I think that is the mechanism whereby feeling arises, then on the argument of Richard Feynman, when Richard Feynman died, written on his blackboard was, if I can't create it, I don't understand it. My dear engineering friend, Tim Dennison, if I can't create it, I don't understand it, said Richard Feynman. And I think that's a very good philosophy. So I think if this really is the causal mechanism whereby feelings are generated, then you should be able to engineer it. It shouldn't be necessarily something that only arises in the natural way that it did, given our evolutionary history. So that's my answer to your question. I hope I haven't now lost all your sympathy and you think I'm a nutter.
Okay, I think we'll take one more question. If you want to continue the discussion, please come to the podium.
I would like to challenge the Brainstem account by those higher level cognition that must operate with consciousness, but it seems it has nothing to do with Brainstem. For example, I think metacognition is a very good example. So several studies try to find whether we can have some kind of metacognitive judgment toward the stimulus that is subliminal. But they actually fail to do so. So it seems that we can only have let's say the confidence judgment to the stimuli that we can actually weigh. And actually some philosophers, I think they argue that the confidence rating is actually a better measurement than visibility rating. If we want to see whether a participant is seeing an object or not. So, but from all the studies that are trying to find a neural correlate of metacognition, it seems that this function has nothing to do with Brainstem. So how do you explain that? Some very higher level cognition, it seems that it can only operate with consciousness, but has nothing to do with Brainstem.
So the question is, again, I'm speaking to this audience, and you can tell me if I've misunderstood your question. The question is that an essential functional feature of consciousness seems to be confidence estimation. That it's not a matter of yes or no, it's a matter of how confident am I that I saw this, how confident am I that such and such is happening, that such and such belief is correct, that this is an essential feature of consciousness. And he says there's no evidence that this gauging of confidence, this cognitive judgment is performed by brainstem mechanisms. So if that's a fair summary of what you've just said, this would be my answer. In my slide here, you'll see that I said here for reflex mechanisms, we have an inbuilt prediction. And then I was saying, but if you're in a novel situation, you don't have a prediction. You're in a state of uncertainty. In other words, this is a measure. Uncertainty is formally the same as confidence. In active inference, which is the computational framework that I was referring to earlier, we speak about statistical confidence as inverse uncertainty, and we speak of it as precision. So this thing of how confident am I, in this diagram, what I'm showing you, I don't have an inbuilt prediction. I don't know what to do. So it's a question of what am I, how confident am I that my current policy is working or is not working? So that's what feeling your way through the problem is all about. That the more that what I'm doing leads to an increased deviation from my homeostatic set point, to that extent, I have less confidence in my policy. I have more confidence in the error signal. In other words, things are not turning out as expected. Again, I must show you, it's tied to affect. In other words, it's good if things turn out as expected. It's bad if uncertainty prevails. So confidence is built into this mechanism. It's tethered to affect, but it's confidence in my action policy. And the palpating of the confidence in my action policy in relation to the error signal, I think, is the essential feature of what consciousness is all about. Are things turning out as expected, or aren't they in the perceptual and cognitive and action realm, tethered to the affect, which gives the thing its ultimate valence. Now, your question is this got nothing to do with the brainstem? What I'm saying is two things. First of all, what the reticular activating system does is it modulates message passing in cortex and other CNS structures. So what we're talking about cortex now. So there's neurotransmission going on in the cortex, which I remind you is not intrinsically conscious. And it is modulated by this brainstem arousal. That modulation is modulating precision in the message passing. It is in fact, confidence that you're talking about. So in physiological terms, what we're talking about is modulating postsynaptic gain. So that's what the reticular activating system does. It modulates postsynaptic gain. And by the way, here's a good opportunity for me to, I'm glad I have the opportunity to add this. It's not only the reticular activating system. Those are the big ticket structures that do this modulation. There are many peptidergic structures, peptidergic functions. There are many other hormonal functions which don't arise from the reticular activating system. What all of them have in common is they modulate postsynaptic gain across different functional states. So it's not just globally. It's got to do with which functional state are you in. The modulation of how well or badly things are going by the reticular activating system is increasing or decreasing confidence in the prediction as opposed to the error signal that flows from that prediction. And that is a brainstem function. That is the function of the reticular activating system. I said it depends on which state you're in. That leads us to the periaqueductal grade. The periaqueductal grade, descending on the PAG, is the residual error signal in relation to just about every homeostat that we have. So all is a massive assembly in PAG after each action cycle. It's a kind of artificial idea, but after each, I've acted. Now, how did it go? all of the residual errors descend upon PAG, and there's a prioritization function. Which one of these error signals is going to take preference? Which one of these is going to govern my voluntary behavior? I think that has everything to do with the fact that the PAG is right next to the superior colliculi, which also is registering what is the current salient state of the environment. So it's like a needs and opportunities, and then a prioritization has to be made. And that again is a confidence judge. How confident am I that I can reduce this uncertainty by the total uncertainty by this means or by that means? So the selection of which state I'm in is also a brainstem function. The ultimate choice of which homeostat is going to be prioritized, certainly in relation to voluntary action, seems to be performed by the PAG. So this whole thing of confidence that you spoke of, we think of it as a cognitive judgment conscious function, but I think that mechanistically exactly that same function is what these brainstem structures are performing. And I think it's a really important way of thinking about what the reticular activating system does, is to think about it when we speak physiologically of modulating postsynaptic gain, we're speaking about modulating confidence. And I like the fact that it also has this psychological connotation, but it really is ultimately a statistical concept. Thank you all for your attention. Thanks very much.